Here we go again. Today, I sound like Mr. Jackson. All right, so Algebra 2, 6.6, solving quadratic equations using the quadratic formula. So this lesson, again, complete review from Algebra 1. We don't make a great big deal about it because um, it's an easy way to solve a quadratic. If you have trouble solving, factoring, this is another way that you can solve it. Sometimes, like I said, the regions can be a little bit specific as to how it wants you to solve it, but I'm going to remind you that sometimes we can back our way into it, or we will always get some points doing it using another method. All right, so now the quadratic formula is x equals, I have it written off to the side here, x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. Back in the day when it wasn't given to you, I'd have my kids sing it. X equals the opposite of b plus and minus the square root of b squared minus 4ac all over 2a. I know, don't quit my day job, I won't. But now that we have it on our reference sheet, now this is not a very good picture of our reference sheet, but let me see if I can make it a little bigger. If you look at this, right here on the top, here is our quadratic formula right here. All right, so far, the Pythagorean theorem we won't use in this. We won't use pretty much anything. We won't use circles, cylinders, spheres, so we pretty much won't use anything here. We are going to do the rest of these in our units following this. So, but we have the quadratic formula. We don't have to be able to sing it or to be able to memorize it because we have it. So just moving back to our question now, the activator, which normally would be the do now in our class, is showing a quadratic, and it says A, they want us to do it by factoring, and B, they want us to do it using the quadratic formula. And you'll see you'll come out with the same answer no matter which way you do it because we're solving it. Some of you aren't so happy with factoring when you have a leading coefficient that is not 1. But let's see what we can do. If worse comes to worse, you could put this into your calculator and you actually will come up with a nice, like if you look at your calculator, over here at 6, you're going to have your root. So you get a nice root here at positives. I'm sorry, my bad, it's negative 6. 6 is the negative 6 is the 0, so my bad, I just wrote that wrong. So when you look at it on your calculator, negative 6, so it'll be over here at negative 6, will be your 0. So you know if negative 6 is your 0, you would know that x plus 6 is one of your factors. So I know this one would have to be 2x, and if I have a negative 6 here, this has to be a minus 1. So you can factor it a little bit by cheating. Sometimes you get lucky. All right, so make sure when if it tells you to solve it, please make sure you're showing the whole thing. Go back to Algebra 1 and say, set's equal to 0, add 1 to both sides, 2x is equal to 1, divide both sides by 2, and x is equal to 1/2, or 0.5. X plus 6 is equal to 0, minus 6 from both sides, because remember, you get credit for showing work. And if you do it all in your head, I can't give you credit for what I don't see. All right, so that's doing it that way. So we have our answers, 1/2 and negative 6. Now we could also use completing the square that we just finished. But if we use the quadratic formula, we know that A is equal to our coefficient for our quadratic term, B is our linear term coefficient, and C is our constant. All right, and now we just plug those into our formula, and we get x equals negative b plus and minus the square root of b squared. Now this is, whether it's positive or negative, squared is always going to be positive. So sometimes what I do right away is, well, I know b is 11, so I do b squared minus 4 times a times c all over 2 times a is 4. So you can do a little bit of the mental math, help you out a little bit. My next step is always to do the discriminant, which is what is underneath my square root. So I just put that into my calculator, and I get negative 11 plus or minus rad 169 over 4. And I know I get rational answers, so I know that I have to be a perfect square here. So I get negative 11 plus or minus the square root of 169 is 13. So 13 over 4. So my answers are going to be negative 11 plus 13 over 4 and negative 11 minus 13 over 4. So the answers turn out to be, obviously, negative 6 is down here because it's negative 24 divided by 4, and here's our 1/2. Okay, so we get 2 over 4. Same answers, two different ways to do it. We could even spend a little bit more time and complete the square and show you how to do that, still get you the same answers. All right, so let's go down to exercise 1. Algebraically determine this function's x-intercepts using the quadratic formula. And A says express your answers in simplest radical form, and B says express your answers to the nearest hundredth. Very rarely are they going to ask you to do both, but I want you to see how they might ask you to solve this. So again, when the time comes and you want to skip the formalities and move right into the quadratic formula, you can. But for now, bear with me. I'm going to put my A, B, and C up here just, whoops, it's a negative 36, just to make sure I am not making any mistakes. So x equals, I would start with writing the formula down. Negative b plus and minus the square root of b squared minus 4ac all over 2a. Again, if you feel comfortable, then maybe you don't have to do that. So the opposite of b is positive 4 plus and minus the square root of b squared, 4 squared, 16 minus 4 times a, which is 1, not even going to write it down, times c, which is negative 36. Because to put the 1 down is just trivial. Divided by 2 times a, 2 times 1 is 2. Right? Again, I just try to simplify things. If you're the kind of person you follow the rules and you want everything, then feel free. Do it your way. All right? So we get 4 plus and minus. Let's do the discriminant. That's what's under the radical. So negative 16, 16 minus 4 times minus 36 is 160. Because it turns into 16 plus 36 times 4. All right, all over 2. So my answer turns out to be, now let's see if we remember this. Yikes, okay. Simplest radical form requires us to take that rad 160 and break it up into simplest radical form. So we look for the perfect square, and right away, bam, I see a 16 in here, which is a perfect square. Remember what your perfect squares are. Perfect squares, let's see. 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10. So that's up to 10. So I know that I can easily take a 16 out of here. So I know I would get square root of 16 times square root of 10. I can't break that up into any further. So if I could, I might try and take out a bigger number. But I'm going to get 4 rad 10 here to simplify it. So I'm going to rewrite this as 4 plus or minus 4 rad 10 over 2. And of course, when you divide by 2, everything gets divided by 2. So I have 2 plus or minus 2 rad 10 is my answer to part A. There's my simplest radical form. And then simply the part B, so my A is 2 plus or minus 2 rad 10. And my B is simply going to be putting this into my calculator. So 2 plus 2 rad 10 is 8.32, rounded to the nearest hundredth. And 2 minus 2 rad 10 is negative 4.32, again, rounded to the nearest hundredth. That's just a calculator activity. I think the simplifying of the radicals is probably, I didn't spend a lesson on that. I was really kind of hoping that, that some of you might remember how to do that. Again, if you got that far and didn't take it into simplest radical form, by the way, if you're doing it to the nearest hundredth, you don't need to bring it to the simplest radical form. All right? And if you left it like this, if you left it in this form instead of bringing it to simplest radical form, you'd lose a point or so. But, again, the bulk of it is done and it's done right. All right? So that's what we're looking for. We always like perfection, but when perfection is not present, we take the closest thing. Taking a look at exercise 2, this is just me talking, but when you have answers that are numbers, we can always use our calculator to come up with this. So it's not the way they want you to do it, but when you have answers that are numbers, we could put this into our calculator, we could find the roots and see which one matches these. And again, these are going to be, so 3 and 2 are both irrationals, which means you're going to get some serious decimals in there. But remember, you're just going to match it to what you get on your graph as far as your zeros go. But how they want us to do it is a whole different story. So let's go through that process. So we have 3x squared minus 19x plus 6 equals 0. Because when you're solving it, y is equal to 0. Your x-intercepts are 0. So x equals the opposite of b plus and minus the square root of b squared. Okay, so you might not know what 19 squared is right away. So you might want to say 19 squared minus 4 times a times c all over 2a. And now put this into your calculator to get your discriminant. Now I'm going to move down. You might have to move to the right. So I'm going to get 19 plus or minus, and when you put that whole thing into your calculator, you get 289. So it's the square root of 289, or rad 289, all over 6. And 289 is a beautiful perfect square. So my answer is 19 plus or minus 17 over 6. So I know that right away, it's not going to be 2, it's not going to be 3. So that kind of takes a little bit of a load off my shoulders here. So I do 19 plus 17 divided by 6, and I do 19 minus 17 divided by 6, and my answers turn out to be 1/3 and 6. So this is equal to 6, this is equal to 1/3, so my answer is right here. Right, but if you had actually put that into your calculator, again, what you would be looking for is something that is 1, 2, 3, 4, 5, 6. You would be showing a 0 here and a 0 here between 0 and 1, and my parabola would look something like this. So again, it just would be so much easier to put in your calculator. And being versatile that way, understanding the concepts and understanding how to flip-flop between the algebra and the geometry, or the graphic representation, is so important in Algebra 2. All right, because it's going to give you such a great foundation as you move into pre-calc and calc. All right, we do have an extra one. We have exercise 3. This one's going to be a little bit longer, so I'm sorry about that. Oh, we did that. So exercise 3. The popcorn factory modeled the percent of popcorn kernels that would pop P as a function of the oil temperature T in degrees Fahrenheit using the equation. Yikes. Okay, so basically what I'm just going to do here is I'm going to take a look at my formula here and try to make heads or tails of it. P is the percent of popcorn kernels that are popping, where T is the temperature of the oil. Okay, as soon as you can make sense of the equation without making complete sense of it, it makes things a little bit easier. The company would like to find the range of temperatures that ensures that at least 50% of the kernels will pop. Write an inequality whose result is the temperature range the company would like to find. Solve this inequality with help from the quadratic formula. All right, so basically what we're doing here is we want to know, it's saying at least 50%. So the actual formula is going to be 50 is less than or equal to negative 1 over 250 t squared plus 12.8t minus 394 is less than or equal to 100. So that's the actual one we're finding. But we're going to use the quadratic formula basically to find our two temperatures. All right, so let's come over here a little bit. I know this is a little crazy with these numbers, but I'm going to remind you, you have a calculator. So I know there are places to make mistakes here, but let's not flip out. So let's just use our 50 here So we're going to get, because if you subtract 50 on the other side, you also get 50. So we can use 50. So negative 1 over 250 t squared plus 2.8 t minus 394 has to be actually greater than or equal to 50. All right. Now you can do this again with less than or equal to 50, and we'll come up with those two numbers. But 50 is still going to be what's on the other side. So you put this whole thing into your calculator, and into your quadratic formula. So t equals the opposite of b plus and minus the square root of b squared minus 4 times a times c. Crumb buns. I have to bring the 50 over first before I can do this. So this is going to turn into 344. Nope. Why do I have 344? Minus 50, minus 50. All right, so I'm sorry, that's not right. So this has to be 444. So this will be 444. All right, all over 2 times negative 1 over 250. Okay, now I know this looks a little nasty, but the beautiful thing is because it's telling us to round all temperatures to the nearest tenth, we don't have anything to simplify here. We're going to put this whole thing into our calculator. So the first thing I'm going to do is I'm going to do the whole thing with a plus sign here. And then I'm going to go back. I'm going to pull it down again. I'm going to change the plus to a minus. And I'm going to get my two answers. And my answers turn out to be 242.8 and 457.2. All right, so I know that my oil temperature has to be between 242.8 is less than or equal to the temperature, which is less than or equal to 457.2. So these real world problems are kind of fun, all right, because it makes sense. It makes sense of things. So exercise 4 says find the intersection points of the linear quadratic system shown below algebraically. Then use your calculator to help produce a sketch of the system. Again, the sketch is really only there so you recognize that you have 2 points, not just x's. All right? So let's just, when you have y equals and y equals, we set them equal to each other. Minus 6x plus 2 is equal to 6x minus 3. And again, we can put this into our calculator to find the intersection points. So that way we know when we are solving this, we get the right answer. So minus 6x plus 3 minus 6x plus 3. And we get 4x squared minus 12x plus 5 is equal to 0. And now we use the quadratic formula. X equals the, now you don't have to use the quadratic formula, you can factor this, but I think some people prefer to use the quadratic formula because it's just so straightforward. So x equals the opposite of b plus and minus the square root of b squared minus 4 times a times c all over 2a. So you put the discriminant into your calculator, because this is asking, this doesn't say to simplest radical form or to the nearest tenth. So you actually could put this whole thing in your calculator because we should come out with a nice number. So actually we do. This turns out to be 64 all over 8. So we get 12 plus 8 over 8, which is 20 over 8, which reduces to 5 over 2. And then we have 12 minus 8 over 8, which is 4 over 8, which reduces to 1/2. So remember, these are my x values. X is equal to. So now we have to go back, and I'm just going to use this area over here because I don't know how much room you still, I think you have enough room. So we can move down a little bit. So I'm just going to remind you, we have to go back and pull up our linear equation, which is y equals 6x minus 3. You can't pull up the quadratic. It just takes a little bit more time. 6 times 5 halves minus 3. So this becomes 3 times 5 is 15, and 15 minus 3 is 12. So my y is equal to 12, and my point is going to be 5 over 2, comma 12. And on this side, I get y equals 6x minus 3. I get y equals 6 times 1 half minus 3. Half of 6 is 3, and 3 minus 3 is 0. So I know this is my point going to be 1 half, comma 0. And again, easy to check in your calculator. How this would look on our graph, our 2 points would be 2.512, so kind of halfway between it, 12. Here would be our first point of intersection. Our other point would be 1 half, comma 0. Here's our second intersection point. And I think what it looks like is something like this. If you put in your calculator, you can kind of see. All right, so that's the end of that lesson. Lots of practice to do with using the quadratic formula. I know there's lots of mistakes that can be made because you can be putting things into the calculator incorrectly, but remember, it's a great tool, but it only does what you will do. Calculators don't make mistakes, but people do all the time. So I've said it a couple of times today. I'm going to say it one more time. Always make good choices, and I'll see you next time.